Ooh, implicit differentiation. Okay, we have no optimization here, but we have a comeback from implicit differentiation, and both of these problems are the same, so I put them on the same slide. Okay, so for the first one, we're going to try to find a tangent line that is the y-axis. Now that means that we have a does not exist slope because the y-axis is vertical. So we're going to take the derivative, which is this guy right here, and we're going to find out where he is not existing. And so we take the denominator and set that equal to 0 because that's what would make that dy dx not existing. And we get two y values. We get 4 over 3 and 4. Now what we're going to have to do is we're going to have to find out which of these y values will give us a 0 for the x. Because if the tangent line is the y-axis, that means x has to equal 0. So in order to find out what the x equals, we're going to have to plug these y values back into the original equation to see which one gives us a 0. Now, I don't know about you. I'm not excited about doing a fraction, so I'm going to do the 4 first. So I'm going to plug the 4 into that original equation and do some simplifying. 4 squared is 16. 16 times 4, and 4 to the third is 64. Okay, so 16 times 8 is 128. And then we have 16 times 4, which is 64. Then we have the rest of the equation. Oh, cool stuff is about to happen. 64 and 64 is 128, and 128 minus 128 is 0. Now we're left with negative x squared plus 2x equals 0. Beautiful. So we factor out a negative x, and then we set each of those factors equal to 0. And we get x equals negative 2 and x equals 0, which is what we wanted. We wanted this guy. So that means the 0 would go with this one. We'll go with the 4. And I don't even have to check the 4 over 3. Beautiful. So that's our answer. It's 4. And just for funsies, here's the graph. That thing looks crazy. And right here we have 0, 4. And clearly there's a vertical tangent line right there. And that it is the y-axis. Okay, going over to the other one where Allison right here is working. We're going to have to solve this ourselves to make sure she did it right. So first we got to find dy dx. So to find dy dx, we're going to have to take the derivative implicitly of this equation. When we do that, we get 2x plus 8y dy dx equals 3y times or plus 3x dy dx. This guy goes away because he's a constant. And then we have to do the product rule with this. That's why I have two terms right here, because of the product rule. Don't forget, whenever you take the derivative of the y's, you're going to have dy dx, because we're taking the derivative with respect to x. All right, so I put all the terms that do not have a dy dx on the right side. You see there's a 3y right here, and then I moved over the 2x. That's why we got 3y minus 2x. And then I put the terms that have a dy dx on the same side. Now the positive 3x dy dx is now a negative 3x dy dx. I factor out the dy dx, and at the same time, I'm going to divide the other side by whatever I'm left over with. And so you see the 8y and the negative 3x. There's the 8y and negative 3x. We took the dy dx out, and then we divided both sides by 8y minus 3x. Sorry, I want to try to write less on that one. And so it checks out. She did that first part right. Now she's now what we're trying to do is we're trying to find out where the line is where the tangent line to the curve is horizontal. So that means we care about only the numerator and where the numerator equals 0. If the denominator equals 0, that means we have a vertical tangent line. So we only care about the numerator. Now she had this extra equation right here. I don't know if that's enough to make step 2 wrong, but it's there. But I crossed it out because we don't really need it. We just need this 3y minus 2x equals 0. And when we solve for y with that equation, we get 2 over 3x. The reason why I did that is because I want to plug this into all the y's into this so I can solve for the x. So that's what I do. I plug in the 2 over 3x. Now it's just algebra right here. I got to square it. I get 4 over 9x squared. I'm going to subtract 2x squared from both sides. And so I get negative x squared plus 16 over 9x squared equals 7. This one has a denominator of 9, so if I can make that one have a denominator of 9, I can easily add those combined like terms. So I make that a negative 9 over 9. Negative 9 and 16 is going to be 7, so I have 7 over 9 x squared. To get rid of the 7 over 9, I multiply by the reciprocal. Cool stuff happens. Those 7s cancel out. I get x squared equals 9, and so x equals plus or minus 3, which is exactly what she got. She got 3 and negative 3. So last thing I need to check are those y values. So I'm going to take the positive 3 and negative 3 and plug it into this guy. You could plug it into this guy, but that doesn't sound like fun. So I'm going to do the easy one and plug in the 3 to that. When I do that, those 3's cancel out and I get a positive 2. Now, it's pretty obvious. If I were to plug in a negative 3, then I would get a negative 2 instead of a positive 2. So that one also checks out. So it looks like she did everything right. Her solution is correct.